Okay, this example, we're considering SAT scores for 2009. We're given the SAT is an exam where scores are normally distributed. So in this particular example, we are asked to randomly select 16 SAT takers for the year 2009. The question is to find the probability that their mean math score was less than 580. We have three areas in the SAT: the reading, the math, and the writing area. We're right now looking at the math results. So from the table, the mean score for the math results was 515, and the standard deviation was 116. Right here you are selecting 16 subjects, 16 SAT test takers for 2009, and you're asked what's the probability that the mean of these 16 is less than 580. In this case, we have that the central limit theorem will have to be applied. We do have conditions to apply the central limit theorem, because in the context of the problem, the original distribution is a normal distribution. So then the means of this samples of size 16 will be normally distributed. These means are normally distributed. So you have a normal distribution for this variable mu. Its mean is mu x by the central limit theorem, that just equals the mean of the original distribution, which is 515. The standard deviation of the distribution of means does have a formula by the central limit theorem. The standard deviation of the means is the same as the standard deviation of the original distribution, that of SAT scores, over the square root of n. In this problem, n is 16. So you say sigma, or the square root of 16, sigma in this case is given to be 116. So the standard deviation of the distribution of the means is going to be 116 over the root of 16. When you do your calculation, this turns out to be 29. So what are we after? We're after the probability that your variable mu is less than 580. So what we're going to do is we're going to convert this variable into a z-score for this normal distribution, the normal distribution of the means. So we find the z-score for 580. Z-score for 580 is 580 minus the mean of the distribution we are working with, which is the distribution of the means. The mean of that guy happens to be 515. This is not correct, it's 515. So I'm fixing it. The mean is 515 over the standard deviation of this normal distribution, the distribution of the means, which we found to be 29. So the z-score is the same as, if I quickly look at my notes, let me just give the calculator answer afterwards. So 580 minus 515 is the same as 65 over 29. When you put this in a calculator, you get a decimal expression of 2.24137 and change. Now, when we look at the z-scores in a table, which is what we're going to employ right now, we need to round off to the nearest hundredth. When you run this to the nearest hundredth, you get just 2.24. So we're going to use 2.24 as our z-score. Now we're going to use the standard normal distribution. We do have to look at the table for that area. What area we're looking at? So right now we have converted this into z-scores, into standard normal distribution. So the mean is equivalent to 0. The z-score is 2.24, which is to the right. So z equals 2.24. What we're looking is for the area under the curve to the left of z equals 2.24. We're looking for this area. Recall that we find that area by looking at a z-scores table, in this case the positive z-scores. When I look for 2.24 in that table, I go down to 2.204. So 2.24 is what you obtain when you combine those. The entry that gives you the area to the left of 2.24 is 0.9875. So this area is 0.9875. That's the probability that z is less than 2.25. But since we had converted that from 580, that turns out to be the same as the probability that our original variable, in this case our variable is mu, is less than whatever this whatever the z-score here represents, 2.24, excuse me, 2.24, not 2.25, represents a score of 580. So we have found the probability to be 0.9875. And that completes our exercise, our example.